Welcome to AI Frontiers, the latest in computer vision research. In this episode, we delve into a curated selection of 63 groundbreaking computer vision papers from September 11th, 2025. This journey highlights advances in AI image generation, open datasets, benchmarking, and the quest for trustworthy artificial intelligence. Join us as we explore how these innovations are shaping the way machines interpret and interact with the world. Artificial intelligence is now capable of generating vivid, detailed images from intricate, multi-step prompts, such as imagining a cat in a detective's hat reading a newspaper in a Parisian cafe at sunrise. Notably, some of these advanced models can also articulate their creative process step by step, offering a window into their reasoning. Recent systems are demonstrating an emerging awareness of their own limitations. Refusing to fabricate answers when encountering unfamiliar inputs. From autopilot features in vehicles to AI-assisted medical diagnostics, computer vision underpins critical technologies. The central question remains: how close are we to achieving truly trustworthy and creative AI systems? Computer vision, the discipline that empowers machines to interpret images and videos, permeates many aspects of modern life. Everyday technologies, from smartphones organizing photos to cars detecting road hazards to healthcare AI analyzing scans, rely on computer vision's capabilities. The latest research is driving this field toward greater creativity, reliability, and fairness. In today's episode, we spotlight open datasets, novel models, and the real-world impact of 63 recent computer vision papers, illustrating how these contributions are shaping the future of AI. Envision computer vision as equipping machines with the ability to see and interpret the world, much like a knowledgeable museum guide describing a painting's colors, shapes, and underlying emotions. In practical terms, computer vision is fundamental to self-driving vehicles, medical imaging, and automated photo sorting. The field is expansive, encompassing tasks from basic object recognition to the analysis of emotional expression within images. Each new research paper functions as a vital building block in this ever-evolving landscape, advancing technical concepts such as image recognition, enabling machines to classify and understand the contents of a visual scene. A pivotal theme in computer vision is the data revolution, where richer and larger datasets fuel the advancement of smarter AI models. The FLUX-Reason-6M dataset exemplifies this progress, comprising 6 million images, each paired with detailed reasoning steps. PRISM-Bench serves as a comprehensive benchmark, challenging models in nuanced image reasoning. In the domain of video, datasets like SpatialVid introduce annotated sequences that enhance scene understanding over time. These resources act as a modern Rosetta Stone for AI, unlocking unprecedented opportunities for learning and performance. The trend toward multimodal learning is transforming AI, enabling models to integrate and interpret multiple data types such as images, text, and sound. For instance, Kling Avatar leverages both visual and textual cues to animate avatars, while Oral enriches dental X-ray analysis with descriptive labels. The Medverse project extends these ideas to healthcare, designing models that adapt dynamically to new medical imaging tasks. This approach, known as multimodal fusion, enables AI systems to synthesize information across diverse domains, creating more nuanced and robust capabilities. Generative models have emerged as the new artists within AI, particularly diffusion models that transform random noise into detailed images. The study, Locality in Image Diffusion Models Emerges from Data Statistics by Zhou and colleagues, reveals that the focus on local image detail in these models is shaped by the statistical properties of the data itself, rather than solely by architectural design. Generative AI now creates not only images, but also videos and three-dimensional scenes, and is increasingly able to reconstruct and explain its own creative steps. This process can be likened to observing a Polaroid photograph gradually develop in reverse, unveiling the underlying structure of the generated content. Key findings from recent research showcase both progress and ongoing challenges in the field. The FLUX-Reason-6M dataset from Fang and collaborators democratizes data access, enabling open research to compete with proprietary efforts. Zhou et al.'s work demonstrates that the local focus and diffusion models is a byproduct of image data statistics. The Humble Bench benchmark, introduced by Zhou et al., highlights the necessity for models to admit uncertainty rather than make incorrect guesses. Medverse, developed by Wang and team, adapts rapidly to new medical imaging contexts. Meanwhile, Liu et al.'s Invisible Attributes, Visible Biases investigates and addresses bias within medical AI systems, illustrating the field's increasing commitment to fairness. The featured paper, FLUX-Reason-6M and PRISM-Bench by Rongyao Fang and colleagues, represents a landmark in dataset and benchmark creation. This resource consists of 6 million images, each annotated with detailed, stepwise reasoning chains, and 20 million bilingual descriptions in English and Chinese. PRISM-Bench rigorously evaluates models across 7 tasks, including compositional reasoning, text rendering, and style adherence. The construction of this dataset required approximately 15,000 GPU days, reflecting the scale and quality of the effort. By making these resources publicly available, the project significantly democratizes access to industrial-scale tools for the global research community. The methodology behind FLUX-Reason-6M and PRISM-Bench is distinguished by meticulous attention to depth and inclusivity. Each image is accompanied by explicit, step-by-step reasoning explanations, providing transparency into model decision-making. The bilingual nature of the data bridges English and Chinese research communities, fostering international collaboration. PRISM-Bench challenges models with 7 diverse tasks, and evaluation relies on advanced vision language models supplemented by thorough human scoring. Despite these advancements, challenges remain. Particularly, current models struggle to follow long and complex prompts, indicating areas for continued improvement. The impact of FLUX-Reason-6M is far-reaching. This dataset enables open-source models to achieve parity with closed-source industrial systems, leveling the playing field for researchers worldwide. The inclusion of reasoning chains supports the development of explainable and interpretable AI, while the bilingual dataset facilitates global inclusive research. Furthermore, the benchmark reveals persistent weaknesses in current generative models, especially in tasks requiring nuanced reasoning. Collectively, these contributions establish new standards for transparency and trustworthiness in artificial intelligence systems. Looking to the future, computer vision is poised for transformative growth. Anticipated developments include even larger and more diverse datasets, empowering models to reason seamlessly across modalities such as images, text, and sound. Trust and humility are expected to become central design principles, fostering systems that can recognize their own limitations. The field's trajectory is aptly compared to a spacecraft embarking on the exploration of new worlds, where interdisciplinary collaboration with ethicists and policymakers will be essential to ensure responsible progress. In conclusion, 63 recent papers collectively illustrate a field marked by ambition, collaboration, and a commitment to broader societal impact. The work of Fang and others is driving forward the democratization of data and the pursuit of explainable artificial intelligence. Trust, fairness, and humility are increasingly prioritized, positioning the next wave of breakthroughs to influence how society perceives and utilizes machine vision. Listeners are encouraged to explore, discuss, and actively contribute to the evolving conversation around computer vision's future. The synthesis of today's content involved a blend of artificial intelligence and human expertise. Summarization was powered by GPT 4.1 from OpenAI, with text-to-speech technology and image generation facilitated by Google Tools. Human experts meticulously reviewed and edited the AI-generated content to ensure clarity and accuracy. Comprehensive references for all cited works have been included for transparency. It is acknowledged that some oversights may remain, and ongoing dialogue with the community is encouraged to further refine this resource. Thank you for joining AI Frontiers. Subscribe to stay informed about the latest research in artificial intelligence and computer vision, with weekly deep dives and insights from experts. Engage with the community by sharing your thoughts, commenting, and helping to shape the field's future. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.